What are signed numbers? In this chapter, we're going to learn signed numbers. So first of all, what are signed numbers? So in real life, we have numbers that could be positive and negative. For example, the temperature. It could be 12 degrees above 0 or 12 degrees below 0. We may not say positive or negative, but in mathematics we can describe 12 degrees above 0 as positive 0 and 12 degrees below 0 as negative 0, or we say minus 0. Similarly, if we have money in our checking account, you have credit, $12 in credit, and that's a positive 12. But if you have $12 in debt, so you over drawing your money, your account, and then you have $12 in debt, and then it's going to be minus 12, or a negative balance. So again, in real life, we may not say it, but we actually have positive and negative numbers. If we draw a number line, so this is we call this a number line. On the number line, we put a 0 in a certain place, and we can do units. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And you can also do negative ones. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9, negative 10, negative 11, negative 12, and so on. You can do negative 13, negative 14, and go on forever. So right here, this dot, 12, make it a little longer here, 12 is means positive 12. So positive sign, the plus sign can be omitted. We can just write it as 12. But minus sign cannot be omitted. So this dot right here is negative 12. So if you think of this number line as the thermometer, and you kind of look at it horizontally, but if you turn it 90 degrees and you can look at it vertically, that's exactly a temperature, like the thermometer. You see above 0, we say above 0 or below 0. So right here is above 0 and here is below 0. But when we draw the number line, usually we draw it horizontally, so we don't have to use that much space. And okay, so that's these are sign numbers, and of course we can have say probably 2.5, or so this is 3 right here, and 2.5 should be somewhere between 2 and 3, and we can have negative 2.5, so this would be negative 2.5. So we can have decimal numbers or even fractions here. So because 2.5 is also 2.5. So we can, with the number line, we can describe all the numbers on the number line. So there are some examples which are very easy. Say if you have a loss of $12, you would describe it as minus 12. And sometimes we also say the east is positive numbers. If it's on the east or west, are negative numbers. So if you say 4 miles east, it will be right here at positive 4. If it's 4 miles west, then it will be negative 4. So we can use also positive and negative numbers to describe the direction, if it's west or east. And next, we're going to try to compare numbers. Of course, all the positive numbers will be bigger than negative numbers. So say 2 is greater than negative 3. Because 2 is credited and negative 3 is dead, or 2 is the temperature above 0 and negative 3 is below 0. So that you can see the numbers. If you look at it vertically like a thermometer, and the top numbers on top will be bigger. And if we put it horizontally, the numbers on the right side are bigger. The numbers on the left side are smaller. So 2 is, of course, 2 is right here, and negative 3 is right here, which is 2 is on the right side of negative 3, so 2 is bigger. And this is also very easy if you use real-life examples. Positive numbers are mean credit, and negative mean debt. So with temperature, and 2 is above 0, negative 3 is below 0. And when we know how to compare positive numbers, so if you have positive 3 and a positive 2, and that would be definitely positive 3 is bigger than positive 2. More money, or you can say higher temperature. And what about 2 negatives? So if I have a negative 3 and a negative 2, and although 3 is bigger than 2, negative 3 is less than negative 2. You can look at the picture, negative 3, because if you look at temperature, so negative 2, negative 3 is below negative 2. Or you can say negative 2 is above negative 3. So if negative 3 is below, then negative 3 is smaller. Or you can, if you think of it as money, negative 3 is you owe the bank $3, and if I owe the bank $2 and then $3, I owe more money than you do. When you owe more money than I do, that means negative 3 is smaller than negative 2. Okay, so this is how we compare numbers, and so you can, if you get confused, you can put numbers on the number line and to compare them. The numbers on the right is always bigger. So for example here, negative 2 is on the right of negative 3. Next, we're going to talk about the absolute value. Absolute value of a number means the distance from this number to 0. From the number to 0. So for example, we use the symbol absolute value, we use the 2 vertical lines. So if you have to do absolute value of 2, well, you can write a positive 2. And you count the distance, so let's draw the number line. So that's 0, that's 1, that's 2. And the distance from 2 to the 0, and it's exactly 2 units. So the distance, the absolute value is 2. We can also do the absolute value of negative 2. And negative 2 is on the left side of 0. And we can count the distance from negative 2 to 0 is also 1 to 2. That's exactly 2. So because the distance always is positive or 0, so you don't get negative answers. So absolute value of 2 is 2, absolute value of negative 2 is also 2. And sometimes we want to compare, for example, numbers like negative absolute value of negative 3 and a negative 3. So you may think they're equal, but they're not, because we have 2 absolute value sign here. Because the absolute value of negative 3 is the distance from negative 3 to 0. That would be 3. So the left side actually is 3, and the right side is negative 3, of course. Absolute value of negative 3 is bigger. Okay, so when we do the problems, we need to pay attention to if there is an absolute value sign. When we compare 0, there are another type of question, so we may compare 0 with a number. Again, we still follow the same rule. The numbers on the right side is bigger. So for example, if we compare negative 2 and 0, negative 2 is smaller than 0 because 0 is on the right side. But if we put an absolute value, say absolute value of minus 2 and 0, that would be bigger, because with the absolute value, we get the answer 2, and the 2 is on the right side of 0. So 2 is greater than 0. Okay. And next type of question is we may do calculation, say absolute value of negative 7 minus absolute value of positive 4. So we will need to do absolute value first before we do anything else. So absolute value, you can think of absolute value as parentheses. So absolute value of negative 7 is 7. Distance is 7. Minus, copy minus. Absolute value of 4 is still 4. So 7 minus 4 is 3. Well, we can do another example. Say negative 2 times negative 3 minus 4 times negative 3. Okay. With this problem, we need to be a little bit careful because there's so many vertical lines. You may get confused. You may think it's absolute value of negative 4, but it's not. So we have to pair up the absolute value signs. So this left goes with this one. So we get absolute value of negative 2. That's positive 2. And this one goes with this one. So that's why it's not absolute value of negative 4. Actually, it's absolute value of negative 3. So absolute value of negative 3 is 3. And the sign between them is a dot. So I copy the dot. And next one is minus. Notice that on the left side of minus, there's no vertical line anymore because this one pairs up with this one. So it's an absolute value of negative 3. It's not negative, absolute value of negative 4. So we copy minus sign, we copy 4 until we see the next absolute value sign right here. And we pair it up with the next one. So that's absolute value of negative 3 again. So we write down 3. And there's no sign between 4 and absolute value of negative 3, which means multiplication. So now first we deal with all the absolute values. Treat them like parentheses. So 2 times 3 is 6. Multiplication goes before subtraction. So we copy minus. And 4 times 3 is 12. So 6 minus 12, and we have not talked about it. This is the problem we were going to talk about in next section. So we're going to see how to solve this in the next section.